This video is going to be covering 8.3, linear functions. Linear functions are functions that can be written in one of the two forms you can see here. Ax plus by is equal to c. This is what we call the standard form of a linear function. And y is equal to mx plus b you may recognize as slope-intercept form. In the standard form, a, b, and c are constants. And there is a rule where your a and b terms cannot both be 0. One can be 0, but not both of them. So some examples of functions that fit the bill as linear functions would be something like 2x minus 1/3 y is equal to 7. So this a, b, and c, they can be fractions, they can be decimals, they can be negative. Any of those things are possible. And one of them can be 0. That's completely okay. We could be missing the x term if the a is 0 and just have a y. That's still a linear function. We could also be missing the y term if the b is 0. That's completely okay. We just can't be missing both the x and y. We need one of our two variables. And again, we can also have that in our slope-intercept form where it looks more like this. What makes these linear functions is that when we go to graph them, what will happen is that we're going to end up graphing something that is a straight line. So that's what makes them linear functions. And we're going to be focusing today on how to graph these linear functions. So that's what the whole video is going to be about, is graphing linear functions. So if you already feel comfortable graphing linear functions, you do not really need to be watching this. So graphing linear functions. We're going to learn a bunch of different ways to do this. But the simplest way, the tried and true method for graphing functions in general, graphing any sort of thing, is to just make a table to find solutions to our equation. And in this case, our solutions are going to be ordered pairs. So we can find these ordered pairs by setting up a table with our x and our y. We can choose whichever variable that we want to plug in to find the other one. So let's just come up with a quick example here. Let's do y is equal to negative 3x plus 1. So this happens to be in our slope-intercept form. And we'll talk about how to graph using slope-intercept form, but for now we're just going to use our table or find solutions to this. So like I said, we can choose whichever we want. You choose some number you think is going to be easy to solve for. In this case, I'm going to say 0 is a nice number to plug in. It usually makes things cancel out, so that's what I'm going to do. So I'm going to go ahead and plug in x equal to 0 and see what happens. If I do this, I get y is equal to 0 plus 1, or y is equal to 1. So I have found one point to put on my little table. I am not required to pick x's. This particular format with the equation solved out for y, it makes sense to choose x as the variable, but I could also choose something like, if I was being a little silly about it, try choosing a y. And that just means I'm going to plug in for y instead, and then I'm going to have to work my way backwards to figure out what x is. So not necessarily the most clever thing to do, but by no means a problem. Because then I can still work this out and find that this is true. We get x is equal to negative 2. So negative 2, 7 is also a point. And we could do this one more time. Ideally, if you're making a table or finding these solutions, you want to find 3 of them. You only need 2 to come up with a line. Once you have 2, you could use a ruler and connect them with a straight line. But the third one, make sure that you didn't make any mistakes. If all 3 points are not in a line, you know one of them is a mistake, and you go back and you try a fourth one. So let's just go ahead. Let's choose another x here. We have a 0, we have a negative. Let's just choose 1. So if x is 1, we have y is equal to negative 3 times 1 plus 1. Our y is negative 2. So now we have 3 different points to plug in here. So we're going to go ahead and graph these and see what our function looks like. So if we want to graph these, it looks like I need to have to negative 2 and 1. And then I go all the way down to a -2 for a y and up to a 7. All right, and then I'm just going to plot those points. The first point that we found right here is 0, 1. So 0 in the x direction, 1 in the y, so we're going to end up there. The second point is -2, 7. And then our final point is at 1, -2. And like I said, if we did a good job with this, all of these points should be on a single line that we can go ahead and just draw right through. You do want to make sure that when you draw this line, go ahead and make it black, that you have arrows on both sides to say that it continues forever and ever and ever. It's one thing that students tend to forget. So this is how you graph a line. The only way it gets more complicated is in the instance, say, especially when we're in slope-intercept form, something like this. When you have a fraction as that slope, that m term of that slope-intercept, this is the big problem, right? So what do we do if that's the case? I lost a 2. If that's the case, you just want to choose smart numbers for your y. And smart numbers will be, or for your x. And smart numbers are going to be numbers that are divisible by 3, because then they will cancel that 3 out. We'll get nice, pretty whole numbers. You really don't want to graph fractions because it's very hard to be accurate on the coordinate plane, especially one that you're drawing up by hand for this thing. So I'm going to go ahead and give us some beautiful points here so we can go ahead and graph. So our first number that's easy and we'll have no problems here is our good friend 0. 0 will cancel out the fraction entirely, so we're going to plug that in. 2/3 times 0 plus 1, well, that's just 0 plus 1. So we got our first point to add to our table. And we do the same thing again. This time, though, we're going to be clever about what we choose. Probably want to choose something that is going to make my fraction disappear. So I'm going to choose 3, because I know if I multiply 3 by 2/3, the fraction's denominator will cancel out. So y is equal to 2/3 times 3 plus 1. Since I chose this cleverly, my 3's cancel out, and I get y is equal to 2 plus 1, or 3. So we now have 3 and 3 as our second point. And we want one more point just to check things. Up to us, we could choose 6. It's also divisible by 3. I'm going to go ahead and do -3 just so we get something positive, something negative, and a 0. Y is equal to 2/3 times our -3 plus 1. Again, those 3's are going to cancel out, but I have a positive times a negative, so I'm going to get y is equal to -2 plus 1. So our last point is -3, -1. And then we're just going to graph each of those. -3, -1 puts me here. The 0, 1 that we have is there. And then 3, 3 is there. And again, we did not screw anything up. They're all in a nice, beautiful straight line. So we can go ahead and draw our line through them. What's going to happen if you make a mistake is you're going to end up with a point like way over here, and you're going to be like, something went wrong. And you don't even have to go ahead and check your work on your other stuff. Just graph one more point, and you'll have these 3 with that 1 standing off to the side, and you'll realize where your mistake was. So that's graphing a linear function using a table.